And that brings us to the last session of today with Ankit Kumar. Hello, Ankit.
Do I pronounce your name correctly?
Yeah, you did. I'm Ankit Kumar, as Edward said.
So yeah, you're actually the last session of our conference, and that's because you're in the States, or are you in Canada?
No, I'm in the United States.
So that's actually quite early in the morning for you. I believe 8 o'clock in the morning.
That's right. Yeah, it is about 7:51.
Yep. So that's why we shifted you as late as possible, because else it would be 4 o'clock in the morning for you.
Yeah, thank you for doing that. Appreciate it.
That's not nice. So you're going to tell us about Azure Functions and .NET 5.
That's right.
And you're actually a member of the Azure Functions team, am I correct?
Yes, that's right. Yeah, I've been on the Azure Functions team for about 2.5 years at this point. Yeah, and I'll be talking about Azure Functions and in particular, the .NET 5 support in Azure Functions that was very recently announced.
All right. Well, I'm really curious about what information you have to share with us. So I'd say take it away, Ankit.
Okay, sounds great. I'm going to start sharing my screen. I believe it should already be sharing.
Yeah, you already did. Okay,
perfect. Yeah. So as I said, today I'll be talking about Azure Functions and in particular, the .NET 5 support in Azure Functions. What I want to get out of this talk is to be able to show you what some of the internal details look like for functions, how different languages and .NET have worked in the past, and how we took advantage of that model to introduce .NET 5. It's a bit different from what you may have been used to if you have used Azure Functions before, in particular the .NET Core 3 support in V3. So it's exciting to talk about why that difference came into play and how you can take advantage of it and what are some of the gotchas that you may need to be careful about. Okay, yeah, as Edward said, I'm Ankit Kumar. I'm a software engineer. I have been at Microsoft and Azure Functions for about 2.5 years. And yeah, this is my first presentation ever giving at a conference. I'm very excited to be here. And I hope you guys get something out of it. Okay, let me move on. Yeah, so to begin this topic, I wanted to first quickly talk about what serverless really means and what it means in terms of Azure Functions as well. This may serve as a very quick intro for those who are not familiar with Azure Functions. And for those who have used it in the past, this may be a very quick refresher. Okay, so when we talk about serverless, there are some basic principles that any serverless service like Azure Functions offer. The first one is a full abstraction of servers. And this is one of the main ideas that any serverless service should provide a managed hosted serverless environment. As a user, when you deploy code to a serverless environment, you shouldn't have to worry about managing these servers yourself. Instance scale. Typically, as a user, you wouldn't have to worry too much about load in a serverless environment. Azure Functions as well takes care of, depending on the plan you choose, it takes care of the load, and as the load increases, it will scale out as needed and scale in when the load is low. Pay per use. One of the core ideas behind serverless is that your code should only be assigned or running in a server when there is a need for it to run. So you should only be paying for what you actually want the code to be running. And yeah, these are some of the guiding principles that also make Azure Functions what it is. On that note, let's talk a little bit about Azure Functions. Azure Functions, as you may know, is one of my Microsoft serverless offering. There's 3 major components to it. The first one is events. Azure Functions is an event-driven serverless model. So things like scaling and even triggering a function itself is dependent on events and where they come from. So if the number of events coming in have increased significantly, your function would scale as required. And this forms a core piece in Azure Functions. And based on when these events do occur, typically your code would execute. And Azure Functions also introduces a programming model not just within Azure, even if you're running it whether in your local machine or in some Kubernetes cluster, it provides a way for you to define these triggers and configuration. And we have these things called bindings, which provide a rich experience and integration with Azure other services, in particular with Azure, where you can use encode directly these services without having to worry about managing directly the services through the SDKs. So when you typically write code, you may have some sort of output that you want to produce through some service. So that is another one of the key components for Azure Functions. Excuse me. In this segment, let's take a look at what a simple Azure function may look like. So we will take a look at a .NET Core 3 function in V3. And yeah, so here's a very simple premise, right? It's like when a queue message arrives, we want to run some code that should be able to fetch a blob. And I'm talking specifically about Azure related services here. So Azure Storage Queue and Azure Storage Blob. We want to fetch some blob and copy it to a new blob. So this is sort of what the function may look like. I did omit a few things like connection string just to avoid cluttering this space. But the idea here is, yeah, and I'm going to break it down piece by piece. But the first part here is that, yeah, that's just a function name, as you see. And this is a queue trigger. So this is the part that specifies when you want to trigger your function, essentially, right? So in this case, we are saying that I want to trigger whenever there is a message dropped in this queue, assuming that your queue is configured properly. And then the message itself comes in the form of this parameter. And then next you have this concept called input binding. So what you could do is you can also tell Azure Functions that when my function is executed, go and fetch this blob from this specific container and provide it to me in the form of a string. And this right here is an output binding. What that means is it is giving you a reference to a newly created blob that you could write to as you run your code. And this part is the actual code itself. We are nothing fancy here. We're just logging the queue message and copying one stream to the other, right? So this is a core idea, very, very simple Azure function that you may look like. Okay, now in this segment, I want to talk about a little more about the internals of Azure Functions and see how different languages and versions and work together and what some of the internal details look like. Before we begin with the actual architecture, let's first familiarize ourselves with some key function components that we'll be talking about. So the first one is Azure Functions Host. So this is a core engine that manages all different triggers, extensions, and it is responsible for dispatching and orchestrating execution. So this is a centerpiece that takes into account when a trigger happens and then dispatches those executions wherever they are executing. And all of this code is open source, and you can find it in the GitHub link that I posted there. And the next thing that I want to mention is extensions. So extensions are libraries that provide binding and trigger definition and associated listener things that may listen for events as you specify things like triggers. So in the example before, when we looked at the blob input and output binding and the queue trigger, so those would be part of these extensions that you may work against. And here's an example of event hubs extensions that you could check out in this GitHub repository as well. So language workers are these programs that provide an execution environment for different languages that may not be able to run directly through Azure Functions Host. Azure Functions Host is written in .NET Core, so any languages like Python, Node, if they have to run, they use sort of this other external piece called language workers. And we'll look more into detail later when we look at the architecture for this. Yeah, and here's another example. This is open source as well, all for language workers. So you can see the Node.js language worker link right there. Okay. Yeah, so I want to mention that there's three major versions of Azure Functions so far. And the major differences in these three versions for our purposes is the target framework, the different functions host targets. So for V1, functions host was built in .NET Framework, which was one of the key components of writing Azure Functions then. And V2, it was .NET 2.2, which is being deprecated right now. And for V3, it was .NET Core 3. So V3 is our sort of main LTS version that we use right now. And V1 is still around because people who want to use .NET Framework still have those apps hosted in V1 Azure Functions. Okay, so now we are going to look at how it works internally for Azure .NET Core 3 function execution. And going into this level of detail, I think, will help you get a sense of what actually happens underneath and may help you make those decisions when you're thinking of choosing one model or the other and thinking about how you can write Azure Functions. Okay, so the key component, as I talked about, is the Azure Functions host process that in V3, that's .NET Core 3, that sort of runs in any environment that you're running, whether that's your local machine or in Azure Functions managed environment or anywhere else. And inside that, we have this, this is sort of an internal detail name, a script host, which is sort of an I host that manages a bunch of different services that are required. But the core idea that I want to highlight is that extensions that listens and respond to triggers are part of this process. This is where all of these extensions are running. Okay, and then you have some sort of function invoker that when something happens, this function invoker comes into play and it invokes the function. So let's say we have a storage trigger function. What happens when a storage event comes in and the extension wants to respond to that? So the extension would recognize that storage event, and then it will call on the function invoker, which will then execute your function. The core thing I want to highlight here is the fact that all this happens in one single process for .NET Core 3. And as you see in this function example, what I mentioned here is a cloud block blob. So this is a SDK type for Azure Storage. And the reason you're able to use that directly as part of your function definition is because it runs in the same process that the extensions are running. So extensions are able to get the data when they trigger and directly sort of call this function with this type cloud block blob. Okay. Yeah. So from the diagram, two things I want to call out again, just to make sure we are clear, is .NET host is written in .NET Core, so it is able to run .NET Core functions in proc. And the fact that .NET Core version support is tied to the host in this model, right? It's like if you want to run .NET Core 3 function app, you would have to use V3 app. You can't use a V2 app and have it run your .NET Core 3 functions, at least not taking all advantage of it. So this brings up the good point is that V3 function app, which is written in .NET Core 3 again, does not run .NET 5 functions in proc. And this should be obviously the previous design we saw, just because everything runs in proc in this model, we cannot host and run .NET 5 functions. Okay, so now the question may come is, how do other languages work in functions, right? Because we do have support for languages like Node, Python, Java, PowerShell, and some others, I believe. And these sort of form an out-of-proc model, which is the model I sort of hinted and I was talking about previously when I was talking about language workers. In that environment, you also typically have these files called function JSON files. And I believe Node and Python definitely do. What that does is it provides some metadata and binding information for each function, what all bindings are required that the host then takes into account to start up the appropriate listeners and invoke those executions. Okay, so now we are going to take a look at what node function execution looks like. in this out of proc model that we call. So here's the function host process that we are talking about, that we have been looking at so far, which is .NET Core 3 here. And again, you have this is the same host that we were looking at before. Nothing's changed here. So you have the same script host, the idea of script host, where extensions still run in the same process here. And then you still have that function invoker. And however, one additional piece here is that there's an IPC server that runs inside a functions host process. And right now, in our implementation, we specifically use gRPC for that. So there's a gRPC server that also runs, and this interacts with this external process, which still runs on the same machine. In this case, because you're using node functions, that would be a node process, which is a process for the node worker that we were talking about and looked previously in the example. And this node function is where your code that you write in function actually gets loaded and gets executed from. So in this model, when a similar storage event happens, the extension again calls the function invoker. But because this is a node function, rather than executing directly because it can't do that anymore, it calls upon the IPC server to communicate with this external process and have it actually manage the execution. So all the trigger data, including the input binding, the output binding, is serialized and sent over this gRPC layer that node worker then deserializes on its end and provides it as parameters to the function. And that's how a node application is able to run on top of this model. Okay. Yeah, and you may notice here is that because this serialization and deserialization happen, you can't directly use the rich types like cloud block plot that we were looking at earlier that was possible for .NET function because again, you have this sort of inter-process communication going on. So that brings us to .NET 5 on Azure Functions. With all that we have seen of how in-proc works, how out-of-proc works, how .NET used to work previously. So now we are going to see how we introduce .NET 5 on Azure Functions and what that sort of looks like. So .NET 5 was announced last year. There are a few major considerations to keep in mind when we talk about .NET 5 long-term. The first one is that it is not a long-term supported version, right? The support for .NET 5 is supposed to end 3 months after .NET 6 is GA. And this is part of the release cadence that .NET adopted recently, in that every November they would be releasing a new .NET version, and all odd number versions would have a short life. Only the even versions, like in the diagram here, you see .NET 6 and .NET 8 would be LTS versions. The .NET 5 is not going to be receiving security patches and bug fixes past even like I think January or February of next year, right 3 months right after .NET 6 is GA. So with this in mind, we are function source. We decided not to move to .NET 5 because we offer a managed service, and it would be a disservice to our customers to not be able to support them long term, because we wouldn't be able to receive these patches, and we have certain commitments to our customers to continue providing production quality service long term and avoid any breaking changes. So we have avoided moving to this .NET 5. So now the question comes is like, then can you run .NET 5 functions in Azure? I mean, of course, from the title of the presentation, and you probably know this, the answer is yes. So this is where .NET Functions Worker comes into play. And this is what I want to talk to you more about. It is based on the same out-of-process model that we were looking at for Node and Python before. And the one key difference here between this model and that is that .NET 5 Worker is shipped as a NuGet package or as a library that you can work against. So in this case, you write the main and you write the actual application, and you just add a reference to the .NET Worker, which then takes care of the communication with the host. And managing the environment. And we'll see that in a similar diagram that we saw for Node, what that looks like. Okay, so and with this model too, we still wanted to keep sort of the same interface that you would be used for in .NET Core, in that there's still no function.json, unlike some of the other out-of-proc languages. And we have some build tools that help us create this metadata, which is different from .NET function.json, that host is able to then read and understand about different bindings and triggers. Yeah, there's still some subtle differences, and we'll look at that when we take a look at the demo of like these types are a bit different, and that has to be, and more on that later. Okay. Yeah. So now that we've talked about all that, let's take a look at the diagram of what this looks like in action. So you have the same .NET host process. Again, there's still written in .NET Core 3. As I said before, we did not migrate to .NET 5 because of its short life. And you still have the same sort of boundary, iHost, script host. Extensions still run in the same, this different process that, which is the Azure Functions host. So no changes there. And function invoker, same way. And there's still the IPC server at play that we looked at for when we're looking at the Node out-of-proc support. And now, instead of the Node process, what you have here is the .NET 5 process that actually runs your code. The slight difference between this and the Node worker model is that the .NET worker is referenced as a library from your user code, versus in the previous Node example that we were looking at, the Node worker was responsible for loading your function. That is, your functions do not have a reference to the Node worker. The Node worker was managed by us and hosted in Azure. In this case, you can manage the version of .NET worker yourself. Okay, so again, very similar storage event example that we have been looking at. What happens? Extensions call upon the function invoker, which then reaches out to the IPC server, and that does out-of-proc communication over gRPC to the .NET worker, which will then execute your code. Okay, with all that in mind, now let's move on to the demo. Let me pull up. Yeah, I hope you can still see my screen. I have here a VS Code environment just to show the general structure and some small changes that we'll require. This is a function app project. Let's start by looking at the CS proj. As you would imagine, this is targeting .NET 5.0, and this is your function project. And it's still running on v3. And there are two key things I want to highlight here is these two. So these are the functions worker libraries that I was talking about. This first one is the worker.sdk. And this is a build tool sort of thing that I was talking about that helps you create metadata during the build. Excuse me. Yeah. So right now, this actually uses source generator, which is sort of a newer thing that we have started using. And that produces some assemblies that are then loaded by the function source. But we are moving away from that model due to some limitations we found, specifically regarding support for, say, like F# or VBasic and stuff. And this is a functions worker itself. This is the worker that we saw that talks to the function source and communicates to it about, in terms of getting the executions and everything. Okay, let's check. Yeah, program.cs. So this is a main program file. And yeah, if you notice, if you have written functions before, specifically for the previous versions, you used to probably never write the main itself, right? So that's a different model that this is adapting as well. In that here you are creating a host builder and running just like you would any other .NET app. So which is sort of a good thing. And this is what really adds the functions worker and all the associated things, right? And the use function execution middleware, this gives you, this has the whole execution pipeline that you're then able to use to execute your functions. And we can do a bunch of interesting things here because you have access to this builder, and we can expose different areas that you can work with. And we'll take a look at one of those examples soon. Okay, let's move on to, yeah, I have one HTTP trigger function here, and this is what that looks like. So very similar to how previous functions and previous .NET versions have worked in functions. However, the key difference here is these types. Previously, you used to be able to depend directly on iAction result or like HTTP request from ASP.NET or system.web and system.net, things like that, right? However, in this case, this is actually our type. And this sort of provides you a representation of the HTTP request and response. Because we want to make it clear that in this out-of-proc model, you're not dealing with the actual request per se. It is the representation of request that is serialized over and sent over gRPC, and that is deserialized on the other end, right? And because of that model, we do have plans in future to add more rich types and make it seem a lot more native and similar to what you used to before. But for now, these are the types that you'd have to work against. And you also have this function execution context, which has a bunch of other interesting stuff, including this items dictionary that we'll take a peek at later. Yeah, you can get the logger directly from this context. And yeah, all it's doing is it's just adding some body and returning a response, right? So let's quickly run this. I believe you could usually run it directly from VS Code too. I know our tooling support is a bit wonky, and we are working towards that. I should mention .NET 5 on Azure Functions is still at a preview stage. So, and I think we do have some tasks.json and launch.json that you could directly use. But I personally just prefer to use this CLI to be able to run my functions. Yeah, and I worked extensively on the CLI too, and that could be the reason why I enjoy it. Working directly here. Yeah, so as you see, your functions work properly as you would expect. And another thing I can do is I should be able to, let's try this. Oops. Yeah. Oh, my bad. Okay. Why is it switching? Okay, yeah, let's start debugging, and I'm going to attach to the process and set up this breakpoint. And now if I run the function, it should hit the breakpoint, and you can take a look at this stuff, right? So you're still able to debug it locally as you would expect. We are working on adding the VS support as integration as well. You could attach a debugger using debug, the debugger.start, I believe, right? I think we have a debugger.launch in VS itself. But yeah, so as you see, the items here is completely empty that we'll be using later. But yeah, if I continue, you should still see the response. Okay, now let's stop this. All right, so now one interesting thing that we have been able to add with this model is a support for sort of middleware. Very similar to what ASP.NET offers, but still different because ASP.NET is built specifically for HTTP. However, in here, we are dealing with all sorts of different bindings. So we provide a bit of a different data types, and you can directly use an ASP.NET middleware here, right? For that, we have this builder, which has this method called builder.use, and you can add to the middleware pipeline directly from there. So I'm going to instead create a new folder called middleware and add an extension to this builder there that will create the files for us. Let me pull up a few things. Okay. So first, I'm going to write the actual middleware itself. Let's call it sample middleware. Oops, I meant to actually put this inside the function app. There you go. Sample middle, right? Yeah, I'm going to copy a bunch of using statements. Right. So we are planning on exposing some interfaces that would make this development easier. But for now, you will have to just trust me on how this is supposed to look like. Yeah. So and I will explain this in a second once I finish writing. Okay. So in this middleware, what we are doing is that, yeah, we've created an invoke method, and that takes in the same function execution context, because every middleware would be operating and should be operating against this execution context, which has a bunch of details, even things like what sort of services are available if you're using DI, and yeah, and like this items dictionary that you can keep adding on to as you move from middleware to middleware, and the next delegate for the middleware. And this function execution delegate is a delegate type, and this is sort of what this is sort of the delegate that defines the middleware pipeline. We build on top of this. So right here, what we will do is, we will just add on to the context.items that we saw earlier, just to show that you can add any metadata, or you could, or you could even just return the request directly from here. But we won't do that today. Middleware, hello. Okay, perfect. And now, in a typical middleware design, it's like, oh, we have added our stuff, and now we just need to execute the next middleware in the pipeline. So I'm just going to call the next the context here. Okay, so far so good. And I will add an extension method to our application builder, like we're talking about. Application builder extensions. Okay. Again, I'm going to be copying some using statements. And I think we can do a bit better here to sort of either provide libraries or build this middleware pipeline by default if you, have registered certain middleware types. But for now, you sort of have to build the middleware or add on to the middleware pipeline yourself. So we want to, because we're extending this, we want to be able to return this as well. So use sample middleware. So we're calling it. And then iFunctions host builder. And this is a builder that we are building on top of, right? Okay, so now in this extension, what we want to first do is we want to first register our middleware that we had just created. So I'm going to do add singleton and add sample middleware. Yeah. Okay, and this is a sample middleware reference that we just created. And then what we will do is this use that I was talking about earlier, we want to call this to register our middleware. Let me peek here to show you what it consumes. So it takes a function that takes a function execution delegate and returns a function execution delegate, very similar to how typical middleware pipelines work. So it looks a bit complex when you type it out, but this is a core idea: is that it takes the next execution function execution delegate in the pipeline, and you want to return your actual middleware that you want to run. So here, I want to return this function that consumes the function's extension context. Actually, let me show you what this function execution delegate is. I think we talked about this previously. But yeah, it takes a function execution context and it returns a task. And this sort of represents the actual middleware itself. Okay. So what I'm going to do is it takes a context and it should, oops, you know what? Yeah, okay, let's do it the right way. And yeah, so what we can do here is we can get the middleware from this context that we registered here. Because again, this function will run when the middleware is invoked during the execution, right? So we have access to the current context, and from there, we will peek at the current instance services, and we can get the required service there, which should be the middleware we registered in when we created this pipeline. Okay, and that's what that is. And now we want to invoke this middleware by calling the invoke function that we created earlier. Typically, this would be some sort of interface type, but for now, this is how it works. Yeah. So that's all there is to creating our middleware pipeline. Oh yeah, I still need to return the builder itself. This is a builder pattern. Okay, and now that we have added this, let me go back to my program.cs and we can call that method, right? Let me add my using Azure function app dot middleware. Yep. Now in here, when we have this builder, we can just call that extension method that we just created. And that's it. So that should create our, add to the middleware pipeline that already exists, this additional middleware that we just created. And I've added a breakpoint here and here. Okay, perfect. So let's execute this. From start again, how we ran it previously. Yeah, and this does a full .NET build, and yeah, and then it just runs the function source. So in this case, the function source is actually running locally here. Okay. Now, if I call this, yeah, so it still works, but that's not what we're interested in. Why does this keep happening? Run, start debugging. Okay. Yeah, so click here. And now if I run this function, yeah, so before my function is executed, my middleware that I defined gets executed, right? And oops, context right now should be empty because we haven't added anything to it. And now here we add it, and then we execute the next middleware in line. And then it reaches the actual function execution. And in the execution, now we see this item that we had added from the middleware. Yeah, so you see this key and the value, middleware hello that we just added. Okay, and if I hit this button, yeah, it should still return the response as you'd expect. Okay, so that's for the middleware support. Now, another thing I want to mention is if you have used functions before, and if you like DI, you know that we did add a couple of years back support for dependency injection as well to be able to directly depend on some specific implementations of instances and reference it from your function. All that is still supported within this model as well. And for that, just for the sake of time, I'm not going to type out the whole code. What I will do is let me create and just copy it. So to add a new folder, STP trigger with DI. And here we're going to create a new function. Let's call that again, STP trigger with DI. Okay. And where do I have it in my machine? Okay. Yeah. Okay. Let me copy this thing. Yeah, so I'm going to copy a bunch of using statements like I have been before first. And now I'm going to copy this entire code. Actually, before I write my function code, let's talk about in which scenario I guess middleware would be useful and what that, dependency injection would be useful and what that sort of looks like, right? So let's imagine that I have an instance and I'm going to do it all in one file. I mean, typically all classes are and interfaces are a separate file, but just for the sake of brevity in this demo. So let's say we have some sort of interface IHTTP responder service that consumes response data and request data. We can add an implementation of that, which I already have here. Right, and this is literally just adding the header and the response body that we were looking at earlier. So nothing fancy here. Yeah, so I'm going to give you a moment. This is a interface and this is an implementation. And what we would like to do is register this implementation for this interface using dependency injection. So now I'm going to write the actual function code to use that service, right? So this is my responder service, and I'm going to have to change the name of this because when I was writing it, I named it differently. Okay, so this is a typical when you use dependency injection, you pass it to your constructor, and it's usually not created. It gets resolved in the runtime. Okay, and I'll also copy the function code. And this should be that. Okay. Yeah, so very similar function, pretty much exactly the same function that what we were looking at previously, except instead of adding the response body, it now calls on this interface that we are using and calls this method. Okay. And now, we need to register the actual implementation first. So as in any host builder, you can call this configure services that takes in the service collection. And on that, you can call the add singleton method. I think I may need to, I just changed this namespace to function app. Yeah. And now we can do this, and then default distributed response service. Okay, so this will register our service. And we are going to set up a breakpoint here just to prove that it actually does hit the dependency injection. From close start, and this sort of, again, we'll do the build and run it. Okay, so we get this function as well. Now, if I call this with DI, it works, as you would imagine. And okay, what I'm going to do is I'm going to hit F5. There you go. Yeah, so now attached to the .NET process, and now if I run it, yeah, we still have the middleware in the pipeline, which is why the middleware first gets executed. And this also shows that middleware will work for all the functions. You can define just a middleware, and whenever any executions happen, it goes through this pipeline. And then now we see that the function gets called, and it does go into the injected service, and that's sort of where it gets the response from. Okay, and yeah, so I think that's it for the DI. Okay, now what we can also do is we can just publish this to Azure. I did create a function app in advance of this demo. What did I call it? 4.NET demo. Okay, perfect. Yeah, so this command should take all your local package and do whatever is required and deploy it to your Azure function app. And you may be used to using tools like Visual Studio to do that directly. And we are planning on adding support to that. We are working on that right now. And we're hoping that before GA, we will have that sorted out. So yeah, it does take a few times. So it kind of creates archive, and now it's going to upload. Yeah, I think my upload speed is not the best. So it takes a little bit. But in the meanwhile, I want to quickly summarize what we saw in the demo. We took a look at this middleware thing that we can add by creating our own host builder and then adding to it on top of the functions worker application builder. And then we looked at the service that we injected with DI, and we looked at how an HTTP trigger function works like and what these different data types mean. Okay. All right, so this is still running. What I can do to save time is I did deploy this before in a different site, and I did run it. So which is this. So you can just believe me that this does execute. And of course, now it won't. Okay, we'll just let this finish. Yeah, I guess it did take a little long, but it did finish execution. So yeah, once it uploads, you will be able to run it directly in Azure, like I did with this function app that I had created before and deployed to it. Yeah, and here you see it come to a deployment. Now it's just going to print out what the functions are and what the invoke URL is. Yeah. It should actually say HTTP trigger here, but this is a bug that we, I believe, have now fixed already. But yeah, so I can show you after deploying what this looks like. Yeah, and this runs as you would expect. Okay, so that's it for my demo. And yeah, and now I want to talk about what we saw and basically look at all different things that you may need to consider if you are thinking of using .NET 5 on Azure Functions, keeping all the gotchas and the new capabilities in mind. So some of the key differences that we saw are, there's no rich type binding support right now. We do have plans to add that. For example, in the screenshot, you see the cloud block blob will not work properly. And we talked about why that is a thing because of deserialization and serialization of triggers that happens when we do this inter-process communication. And actually, in this example, it's not as important, but this file access.read should be file access.read write for cloud blob to work. But even then, it wouldn't work in this model. We do have plans to see how we're able to support it in the future, but more on that in future. And as we saw, there are different parameter types like HTTP request data, and these types that are defined by the functions worker itself. And just by moving out of process and executing in a separate process, there are some startup penalties, and also the fact that there's an extra communication layer that happens with gRPC. You may need to take into account some of those performance differences if you are thinking of moving from .NET Core 3 if you use that, or even if you're just planning on trying .NET 5 in Azure Functions. And right now, all of this is still in preview support. So now, new features that we looked at. The first one is better isolation. So running in different process actually means that there's better isolation between the host and the function code. Although we did use separate assembly load context previously, when it was running in process for .NET Core 3, there was still could be some shared types that we've had issues with in the past that we have fixed. But in this model, you sort of get much better isolation because you are in control of the stack and in your process, so you can depend on whatever you'd like. Middleware support, as we saw in the examples, running it just like separately, like how we did, we were able to add middleware on top of the typical execution environments. And they are similar to ASP.NET, but still vastly different in what data types you interact with and how you register them. Independent updates, because you reference functions worker from your app and you deploy the entire worker, and it's not available to you by default in the managed environment. You are in control of that worker version, and you don't have to depend on the managed service to get updates or even to use an older version or something. So now I would like to end with like what's next for this model or in this Azure Functions in general. So one is for .NET 5, so far what I've been talking about, the support is mostly for Linux and the tools. Support is the deployment in Azure and everything is only supported in Windows right now. So we are planning on adding that support for Linux. And as I was talking about how different tools like VS and VS Code extensions for Azure Functions still don't work very well at the moment. So we do have plans to add that, even including like creating a new function. For right now, you have to copy from samples. So we want to add the templates, and we are working on that at the moment. And we do want to make some performance improvements to make sure that you're still able to take advantage of all of these new features and not have to pay huge penalties on performance. Better binding support, as I've talked about a few times, the fact that it's running out of process, you lose a lot of those rich binding capabilities and the first-class support that you had before. So we are looking on ways that we can still give you that sort of advantage. Yeah, and we're looking forward to GA. We don't have a specific date, not that I'm aware of, but it's going to happen soon. And this brings up interesting points like what about .NET 6 support? So .NET 6 is an LTS version. So we are expecting that it would be, at least what I anticipate is that we would move the function source to .NET 6 in future when it comes out. And we would have some sort of the in-proc support to make sure you're still able to use that in production. And while we still think there's a lot of advantage in this out-of-proc model, so we may still continue making sure that out-of-proc model is still supported for .NET 6 right away. And you might be able to choose between the two. At least that's how I foresee it happening. Okay, with that, I would like to end this presentation. I want to thank you for your time and attending this virtual conference and attending the talk. I hope that you learned something new and enjoyed taking a look at some of the details on how it works internal. And I know as a user, you may not have to worry about the exact details of how these sort of things happen, but I think it's still advantageous to see what different models look like, how they work behind the scenes. So you have some idea of like what to choose when you get a chance. And yeah, so please check it out. This is our preview repository where we have the samples and instructions on how you can run and deploy it today. Let us know what you think of it. Please give us feedback. We are tracking for GA. And yeah, thank you, everyone.
All right. Thank you, Ankit, for your great session. I especially like the parts on where you started with the how does it actually work under the covers, and also the addition of the middleware stuff really brings out new things you can do. That's a big improvement, if you would ask me.
Yeah, I'm glad.
So thank you for that great session. We have one question from the audience.
Okay.
And there was quite a bit of discussion on this particular topic in the YouTube chat. So I hope you can shine a bit of light on this one. The question is, will the next LTS version of the .NET, will it also be out of process from now on, or will the next LTS version will again be an in-proc version?
Yeah, so I think as I briefly touched on this in the last slide on what's next, what I envision and what we are thinking would most likely happen is, because the next version of .NET is LTS, we would still continue that in-proc support, at least definitely, but in the same way, the out-of-proc support is very easy to ship to market, because once we have this worker ready, fully fleshed in GA, we would be able to simply upgrade that version to .NET 6, and you would be able to use it right away. But I do foresee us having the in-proc model as well. Obviously, like until like when that happens, we'll see. Like when the time comes, I can't speak for all of it, but yeah, that's what I would say. It's like we would most likely have an in-proc support like we did for .NET Core 3, and also be able to update this out-of-proc model to .NET 6, and you may be able to pick between what you would like to run.
Right. That does make sense. All right, thank you for answering that. Then you also have a question for our audience, and the prize for the next question is again a Microsoft Power Bank that you can actually win with a nice Microsoft Azure logo, etc. on top of it. So Ankit, could you please ask the question for our audience?
Yeah, and this should be I'm fairly simple if you follow the presentation, but my question to you is, in V3 Azure Functions, what target framework does Azure Functions host target? That's your question. I can repeat it again. In V3 Azure Functions, what target framework does Azure Functions host target?
All right, thank you. So we are going to wrap up shortly here. So we obviously can't answer or make the prize winner available here live on the stream. We will obviously contact the prize winner through Twitter or any other channel. We will make sure that we can reach you. So please do answer that question on Twitter, and we will get back to you. So over to you, Eduard, to answer the question from the previous session.
I'm not going to answer a question. I'm going to draw a winner. So Yeah, thanks Ankit. We have one winner to draw. That is John Bruin. So John, you're the last winner of a YubiKey. And we're going to announce the winner of Ankit's question later on through Twitter. So I think that's it for now for .NET Conf. We want to thank all the attendees. I believe we've been at around 300 attendees at top, so that's really really nice to see. We have a lot of people and some great sessions, and obviously we're looking forward to organize more and more sessions, maybe even in person again. So I hope that we will meet again. I do want to thank a couple of people, and I've got a list here just to remind me. Of course, I want to thank all our speakers. That's Stacy, Henry, Irina, Erwin, of course, Gerald and Ankit. Thank you very much for taking time for all this session preparation and stuff. It was awesome. I want to thank 4Dotnet, our main sponsor. They made it all possible. We have a huge video setup here. We have some video guys doing video stuff. We have a stream guy making sure that the stream is all correct and stuff. I want to thank Microsoft for adding some swag to the swag boxes and providing 2 power banks as a giveaway. And of course I want to thank Wolfstar Media. Those are the video guys doing the actual technical stuff. So they made it all possible. Thanks everyone. And I think that concludes the entire conference for now. So I think this is a good time to cut off the stream, and hopefully we'll see you soon. Thank you.